In this discussion video, we will do some infinite limit practice problems involving non-algebraic functions. So non-algebraic just means that they're going to be functions that don't necessarily just involve powers of x or things like roots. They involve other types of functions. So I want to first look at worksheet 4, problems 7, part G and F, and give you 3 minutes to try these. So pause the video in 4, 3, 2, 1. Pause it and try these for about 3 minutes combined. Alrighty, so hopefully you did that. Hopefully you paused it and tried these for about 3 minutes or so. Let's talk about it together now. So in G, maybe as a first step, we could try plugging in. That would give us arctan of ln of infinity. And then we need to know, well, what is ln of infinity? So if we weren't sure, we'd have to remember, well, what does a graph of ln look like? So y equals ln of x, that graph. So that graph looks like this. And then I just think about what happens as x goes to infinity. As x goes to infinity, that is this part of the graph. And on that part of the graph, the y values are also getting bigger and bigger and bigger and bigger. They're going to infinity. So that is what ln of infinity is. So we get arctan of infinity. So now we need to know what that is. So we have to recall the arctan graph. So y equals arctan of x. Remember, arctan is just another way of saying tangent inverse. Okay, so let me draw my axes. This graph has two horizontal asymptotes, one at positive pi over 2 and one at negative pi over 2. So let's draw those in. Draw in those asymptotes. And then the graph has this shape. It goes close to that asymptote, sort of snakes up, and then goes close to this asymptote at positive pi over 2. So looking at that graph, we want to know what is arctan of infinity. So as the x we plug in is getting bigger and bigger and bigger, that is this part of the graph. And over there, the y values get super, super close to pi over 2. So that is our answer. That is arctangent of infinity. All right, let's do part H now. Same function, just a different limit as x goes to 0 from the right. Okay, so with this, if I started off by plugging in, we get arctangent of ln, and I'll write 0 with a little plus sign. Okay, because I can't just plug 0 in straight up, because ln of 0 is undefined. And because this is already a one-sided limit, let's be more precise. I'm plugging in something slightly bigger than 0. So let's refer to our ln graph. As x gets really close to 0 from the right, that is this part of the graph. And over there, the y values are going down to negative infinity. So this is arctan and ln of 0 from the right. That is negative infinity. And now let's refer to the arctan graph to know what arctan of negative infinity is. Now for this x, we're going to be plugging in values that are going to negative infinity. And that is going to be this end of the graph. And as we go that way, the y values approach negative pi over 2. So this is negative pi over 2, and that is our answer. Let's do another practice problem. So this question is not from one of our worksheets. It's one of my own practice problems, just a separate practice problem. And I have this limit as x approaches infinity. And we have these exponential functions on the top and on the bottom of this fraction. I want to first give you 2 minutes just to focus on how we'd get started. It's probably not going to be enough time to finish the problem. So just focus on what the key steps are in getting started. 4, 3, 2, 1. Pause it. Try for 2 minutes. If you think you have an idea, pursue it for about 2 minutes. Even if you don't have an idea, I want you to try something for 2 minutes. That is super important. All right, so hopefully you did that. Hopefully you paused it for about 2 minutes to try this. First, let's try plugging in. If I do that, I get 4e to the infinity minus e to the negative infinity over e to the 2 times infinity is infinity, and then plus e to the negative infinity. So now I need to know what e to the infinity is and what e to the negative infinity is. We've seen e to the infinity in lecture. Recall, we could get that using the graph of y equals e to the x, which has this exponential growth shape. And on that graph, as x goes to infinity, that is this part of the graph. And over there, the y values are also going off to infinity. So e to the infinity is infinity. And if I have e to the negative infinity, now I need to let this x value go to negative infinity. That is this edge of the graph. And on that edge of the graph, the y values are getting super, super close to 0. So e to the negative infinity is equal to 0. Another way that I could have seen that is e to the negative infinity is 1 over e to the positive infinity. And I know e to the positive infinity is infinity, and 1 over infinity is 0. So that's another way I could have kind of algebraically simplified that to see that it's 0. So if we continue to simplify this, 4 times e to the infinity is 4 times infinity, which is infinity, and then I'll get minus 0 over e to the infinity is infinity, and then plus 0. We have infinity over infinity now, which is an indeterminate form. An indeterminate form. I cannot just cancel these infinities and say the answer is 1. Because when I write infinity, that just means it's a huge thing. It doesn't necessarily mean these two huge things have exactly the same size. Okay, so let's try using one of our strategies from infinite limits, even when we had non-exponential functions, just like powers of x. And that was to factor the dominating term. We're going to factor the dominating. In this case, it's the dominating exponential term, because all the terms are exponentials. So I'll write exponential in parentheses, factor the dominating exponential term. Okay, so I want you to think about what that dominating exponential term is on the top, what that dominating exponential term is on the bottom. Try to factor it out, and I want to give you about 3 minutes to try the problem from here now that we have this strategy in mind. 4, 3, 2, 1, pause it, and try this for about another 3 minutes. Alrighty, so hopefully you tried it for about 3 minutes. Let's talk about it together. Alright, so we have this limit as x goes to infinity. And I can see what the dominating terms are from when I plugged in. When I plugged in, e to the infinity was going to infinity. E to the negative infinity was going to 0, so the infinity term is definitely bigger. So on the top, the dominating term is that e to the x. Similarly, on the bottom, it's going to be the e to the 2x. All right, so I'm going to factor those out. On the top, I'll factor out e to the x. That'll leave me with 4 from the first term. And then minus, I'll have e to the negative x over what I factored out, to e to the x. And on the bottom, we are factoring out e to the 2x. That term is growing most quickly. And then times 1 plus, we'll have e to the negative x divided by e to the 2x, because I factored out e to the 2x. All right, so we can cancel a little bit with the e to the x. And the e to the 2x, when I subtract those exponents, I'll be left with e to the x on the bottom. All right, and now let's simplify a little bit more. I have the limit as x goes to infinity. 4 minus, if I bring this e to the negative x term to the denominator, I'll get 1 over, e to the x times e to the x, which is 1 over, here I add the exponents, and I get e to the 2x. So 1 over e to the 2x. On the denominator, I have the e to the x factored out, times 1 plus. If I bring this e to the negative x to the bottom, and I combine it with e to the 2x, we'll get 1 over e to the 3x. All right, now let's try plugging in. We will get 4 minus 1 over e to the 2 times infinity is just infinity. On the bottom, I get e to the infinity. And then times 1 plus 1 over e to the 3 times infinity is still just infinity. All right, this is going to be 4 minus, this is going to be 1 over something huge, which is getting close to 0. E to the infinity is going to infinity. And then times 1 plus 1 over something huge is getting close to 0. So overall, we have, let's write this, here. This is 4 over infinity, which is getting close to 0. And that's our answer. All right, so I want to end this video with a follow-up question. And the follow-up is, well, what if this was the limit as x goes to negative infinity of the same thing, of 4e to the x minus e to the negative x over e to the 2x plus e to the negative x. With this, if I were to plug in as a first step, I get 4e to the negative infinity, and then minus e to the, it'll be negative infinity, which is positive infinity, over e to the 2 times negative infinity is negative infinity, and then plus e to the positive infinity, that negative x will change the sign. And now the question I want to end with is, with this expression, I need to think about which terms dominate the growth. And that question I'm going to leave as an exercise for you to think about. And once you know the answer, that's going to be the key to simplifying and being able to evaluate this limit.